What is the length, y, and the radius of the quarter circle? Reconstruct the figure as a semicircle. Label points B, C, D, and E. Join line E, C. Since angle D equals to 90 degrees. It is because angle in a semicircle equals 90 degrees. Let angle C be equals to theta. The center of the circle is given as O. It implies that line B, O equals to line C, O which equals the radius, R of the quarter circle. Also, join line B, E. Since line B, E equals to line E, C. BE, C is isosceles triangle. It follows that angle EB, C equals angle C which equals to theta. Hence, angle BE, D equals 2 times theta. It is because the exterior angle of a triangle equals to the sum of the two opposite interior angles. Consider triangle B, E, D. By Pythagoras' theorem, the square of line B, E equals the sum of the square of line D, E and the square of line B, D. Substitute values and we have that the square of line B, E equals the sum of the square of 6 and the square of 8 which equals 100. Take the square root of the equation. Hence, line B, E equals the square root of 100 which equals to 10 in centimeters. It implies that line B, E equals 10 centimeters which equals to line EC. Also, line BD divided by line B, E equals sine 2 times theta which equals to 4 divided by 5. After simplification, by trigonometric identity, sine 2 times theta equals 2 times the product of sine theta and the square root of 1 minus the square of sine theta which equals to 4 divided by 5. After substitution of value, square the equation. It signify that for times the product of square of sine theta and 1 minus the square of sine theta equals 16 divided by 25. Let the square of sine theta equals to x. It means that the product of 4x and 1 minus x equals 16 divided by 25. Expand bracket and we obtained a new equation as shown on the screen. Cross multiply and we have that the product of 25 and 4, x minus 4 times the square of x equals 16. Open bracket. 100 times x minus 100 times the square of x equals 16. Rearrange terms in one side of the equation. It implies that 100 times the square of x minus 100 times x plus 16 equals 0. Divide the equation by 4. We obtained a new equation as shown on the screen. Factorize. We have that 25 times the square of x minus 20 times x minus 5 times x plus 4 equals 0. Hence, the product of the 5 times x minus 4 and 5 times x minus 1 equals 0. Either 5 times x minus 4 equals 0 or 5 times x minus 1 equals 0. Therefore, x equals 4 divided by 5 or x equals 1 divided by 5. Which equals to the square of sine theta as shown on the screen. Take the square root of the equation. It follows that sine theta equals 2 divided by the square root of 5, or 1 divided by the square root of 5. But sine theta is not equals to 2 divided by the square root of 5, as can be proved from right triangle BED. Hence, sine theta equals 1 divided by the square root of 5, or in rationalized form as square root of 5 divided by 5. We call it equation 1. From triangle BOE, use trigonometric identity. Line EO divided by line BE equals sine theta. Substitute values of equation 1 and that of line BE. It implies that line EO divided by 10 equals the square root of 5 divided by 5. Cross multiply. Line EO equals 10 times the square root of 5. All divided by 5, which equals to 2 times the square root of 5. By Pythagoras' theorem, the square of line BO equals the square of line BE minus the square of line EO. Substitute values. It signify that the square of line BO equals 80. After substitution of values, take the square root of the equation. Line BO equals the square root of 80, which equals the product of 4 and the square root of 5. But line BO equals to R, which equals the sum of EO and Y. Solution to question I. 4 times the square root of 5 equals to the sum of 2 times the square root of 5 and Y. Make Y the subject of the formula. We have that Y equals 4 times the square root of 5 minus 2 times the square root of 5, which equals the 2 times the square root of 5 in centimeters. For solution to question II, the radius, r of the quarter circle equals to line BO, which equals 4 times the square root of 5 in centimeters.